Good afternoon. Today we're going to do the kinetic sand experiment. For this experiment we're going to use sand, some water, some dish soap, cornstarch, and stirring instruments, and about a tablespoon for the cornstarch. We're going to go ahead and put about a tablespoon. And the video said that you could put a little bit more, and I'm not sure that I have quite as much or as little as the video. So I'm going to put just a little bit above even on this. Just kind of overflow it. There we go. Set that down. Now, with the water, we're just going to put a couple of drops of Dawn in the water. Go. 1, 2, and stir it around. I'm going to use the other end real quick. Go ahead and get this nice and evenly distributed. Just stir it up a little, and then we're going to drop it in drop by drop and see how it reacts. Alright, we took a little bit of time to continue stirring. I added a little bit more cornstarch because I added a little too much water. But as you can see, the consistency here is moldable. You can create things out of it. Let's see, it still falls apart, kind of almost like a slow moving liquid, you know. That gets, let's see, when you put it back down in here, you can see if I hit on it, it kind of creates a wave through the, because it's still that very fluid consistency. It's getting a little drier. I may have put a little bit too much cornstarch in there, but it is doing what we were wanting it to do. So let's talk about the kinetic sand for a minute. The kinetic sand that we built here is made out of cornstarch, water, and sand, which builds a lot of the same polymers and a lot of the same connecting characteristics as to the commercial kinetic sand, which is polymethylsiloxane. The big thing about these polymers that make kinetic sand flow the way it does as a non-Newtonian fluid is the hydrogen bonds. The hydrogen bonds are very easily broken when force is applied. So that idea, as you saw earlier, that I can mold it into something, but then as soon as I applied just a little bit of force, then it started to break apart like sand again. The hydrogen bonds are the key to that particular characteristic of kinetic sand. And this leads to the ability to mold, but you can also cut. And so if that force is applied directly into one area, then only those hydrogen bonds that are in line with that force are cut. And that's why the sand retains its own form when you cut it. whatever the clumps are shaped in, and it only affects the middle because it's wherever that force is applied that affects the overall um, connections of those hydrogen bonds. And thank you, and have a good night.